any polynomial whose degree is exactly 2. So we say that's a quadratic equation. For an example, if I say 2x squared plus 4x plus 5. So this is a polynomial as well as this is a quadratic equation. You can say quadratic polynomial. So the general expression for quadratic equation goes something like ax squared plus bx plus c. You can say y is equals to. Now, if I talk about solving any quadratic equation, the first method goes like factorizing by splitting the middle term. So I have to factorize in order to find the roots of your quadratic polynomial or a quadratic equation. So let me take an example. Let's say I have 2x squared plus 10x minus 20 minus 12 is equals to 0. So now I need to find the factors or the roots of this polynomial. The best way to do is so splitting the middle term. So in order to do that, first step is I have to multiply my first and the last term, first and the third term. In other word, you can say the coefficient of x square and a constant term always. So even if it is like, if it is in the other form, let's say it had 10x minus 12 plus 2x square equals to 0. So in this case, I won't be multiplying my first and the last term. So the first thing you have to do is the general form of a quadratic equation goes something like ax squared plus bx plus c. So before you multiply your first and the last term, so you have to arrange it in this order. So now if I think about multiplying my first and the last term, so it is going to be 2x squared times minus 12. So which is nothing but minus 24x squared. So I have to find the factors in such a way that, so when I have to find the factors of 24x squared in such a way that when I add them, I should get 10x. So the best thing, what you can do is, so you have to get minus 12, 24x squared. So the factors for 24 would be, let's say 12 times 2. So in this case, 12 times 2. And if you do it like minus 12 and positive 2. So minus 12 and positive 2. So when you multiply it, so you'll be getting 24x squared. And when you add it, you'll be getting minus 10x. So that is the reason it should not be minus 12 and positive 2. So instead, it should be positive 12 and minus 2. So when you multiply them, you will be getting minus 24x squared. But when you add them, you will be getting 10x squared. So that is the reason this middle term 10x can be splitted as 2x squared. I keep it as it is. So 10x can be splitted as 12x minus 2x. Minus 12 stays the same. So this is what it means by splitting the middle term. So 10x, I just splitted it like 12x minus 2x. Now out of these two, I can factorize 2x common. So I'll be left with x plus 6. And among these two, I can take minus 2 common. I'll be left with x plus 6 again. So this can be further written as 2x minus 2 times x plus 6 is equals to 0. So whenever any two terms is equals to 0, this is possible only when either a is 0 or b is 0. So now similarly, if I talk about these two factors, so this is only possible either this term is equals to 0 or this term is equals to 0, which means either your 2x minus 2 should be equals to 0 or x plus 6 should be equals to 0. So then if I solve for x, so in this case, x would be positive 1 or x would be negative 6. So this is the solution to this given quadratic equation. So now if I talk about the second method of solving the same sum, so let me take the same example. My example was 2x squared plus 10x minus 12 is equals to 0. And we got the answer as x is equals to positive 1 or x is equals to negative 6. So now if I think about solving the same quadratic equation using a completing the square method. So in a completing the squaring method, the first step is if you have any coefficient of x square, you have to take that common. So if I take that common, so it would be 2 into x square plus 5x minus 6 is equals to 0. So if you want, you can send the 2 to the other side. So it will be just x square plus 5x minus 6 is equals to 0. And the next step is you have to write the first two terms, and whatever the coefficient of x is, you have to add and subtract with the squares of half of the squares of your coefficient of x. So which means here the coefficient of x is 5 and half of 5 is 5 by 2. I have to add with the square and also I have to subtract with the squares, and the minus 6 remains same. So now these three terms looks like an identity. So which is, let's say I have a square plus 2ab plus b square. So whenever I have this, so this can be written as a plus b whole square. So as you can observe here, so in all the completing squaring methods, so whenever you're solving any quadratic equation using the completing the squaring method, always the first three terms will follow either a plus b whole square, or it can also have something like a minus b whole square. So in this case, this looks like a square plus 2ab plus b square. So in place of a, I have x, and in place of b, I have 5 over 2. So that is the reason this can be written as x plus 5 over 2 whole square minus, so this is about the first three terms. So now if I simplify this term, so this is going to be minus 25 over 4 and minus 6 is equals to 0. So now if I simplify this part, which is x plus 5 by 2 whole square, and this is, if I take the common LCM would be positive 4, and it would be 6 times 4 is 24, so minus 25 minus 24 will be minus 49 is equals to 0. So now if this minus negative 49 moves on to the other side, so it would be x plus 5 by 2 whole square is equals to positive 49 over 4. Now if I take this square to the other side, it will become square root. Not just square root, it will become plus or minus square root of that. So in that case, this will be equals to plus or minus square root of 49 over 4. So which can also be written as, and also this 5 by 2 can be taken that side. So it would be negative 5 by 2 plus or minus. So root of 49 over 4 is nothing but 7 by 2. So whenever I say plus or minus, it could be either of the two cases. The one case is minus 5 by 2 plus 7 by 2. So which is nothing but minus 2 by plus 2 by 2. So which is positive 1. Or it could be minus 5 by 2 minus 7 by 2. So which is nothing but minus 12 by 2, which is minus 6. So I got the same method. So same answer or the same solution for the quadratic equation as I got it with the splitting the middle term and factorizing it. So this is the completing the squaring method looks like. So now if I talk about solving any quadratic equation using the formula, let me take the same example. So my example was 2x squared plus 10x minus 12 is equals to 0. And we got the solution as x as 1 or negative 6. Let's check, do we get the same solution or not? Of course, you should. So in this case, whenever you want to apply a quadratic formula, you have to always compare with the general form, which looks like ax squared plus bx plus c. So if I observe this, so in place of a, I have 2, And in place of B, I have positive 10. And in place of C, I have negative 12. So now, if I substitute these in a quadratic formula, it goes something like this. So x is equals to negative, B value is 10, plus or minus root of B is 10. So that is the reason it is 10 square, minus 4 times A is 2 times, and C is minus 12, and divided by, so you'll be having 2 times A is nothing but 2. So in this case, I can say x is equals to negative 10 plus or minus 10 square is nothing but 100, and this minus into minus will become positive. So 4 into 2 is 8, so 8 into 12 is positive 96, divided by 2 into 2 will be 4. So in this case, I can say minus 10 plus or minus. So this is root of 196, and square root of 196 is nothing but 14 over 4. So now since I have plus or minus, this can be splitted as twice. So it could be minus 10 plus 14 by 4, or minus 10 minus 14 by 4. So which is nothing but this is positive 4 by 4, which is positive 1. And this is negative 24 by 4, which is negative 6. So these are the solutions for the given quadratic equation. So this is how I can solve a quadratic equation using a quadratic formula.